Hello everyone, my name is Okenwa Nathaniel Chomoba. This is school project on data communication, networking and networking. The topic today I'm going to discuss, which is in OSI module, physical and data link layer, network layer, transport layer. First of all, OSI module is specifically designed to set of protocol. The OSI module is specifically designed set of protocol that govern communication channel through which network devices will share information and data. I'm going to discuss some layers of OSI module. Like I said before, physical and data link layer, network layer, and transport layer. At the end, I will show sample configuration using Cisco packet tracer. Physical link layer is the first layer in OSI module, which is also the last layer in descending order of the OSI module. It moves data in form of electromagnetic signal across a transmission medium, while data link layer is the one of the most critical layer in OSI 7 model. Everything above this point relies on device-to-device communication which the data link provides. When you are sending or receiving data to or from the internet, just know that the data layer is supporting the transfer of that data. This is OSI module complete 1 to 7, which physical layer is number 1, data layer number 2, network layer number 3, transport layer number 4, session layer number 5, while 6 and 7 is presentation layer and application layer. While physical layer transmit low byte stream over the physical medium. Data link layer defines the format of data on the network. Network layer decides which physical path the data will take. Transport layer transmits data using transmission protocol including TCP and UDP. Session layer maintains connection and is responsible for controlling ports and session. Presentation layer ensures that data is in a suitable format and is where data encryption occurs. Application layer, human-computer interaction layer, where application can access the network services. So now, layer 2 network, which is the data link layer, runs through layer 1 physical layer, which means it requires a function of physical layer network to operate. Data link network can run on different types of layer 1 network, which is the physical layer like copper, fiber, Wi-Fi, and provide the same capability. Data link layer provides the control access to the physical medium. Some functions of data link layer include the data link layer connects upper layer processes to the physical layer. It places data on and receives data from the network. When network layer packet doesn't have a way to get across through the physical media, the role of the data layer is format this data packet into frames and send them out over the network. It also provides data delivery between Ethernet devices. Data link layer is subdivided into sub-2 layers. One is logical link control and the media access control. The logical link sublayer prepares data for transmission, frames the network layer packet, and identifies network layer protocol. The media access control sublayer regulates the placement of data onto the physical medium or network. It addresses the frame, marks the beginning and the end of the frame of a frame. Network layer is responsible for logical addressing and routing data packet from source device to destination device across multiple networks. Network layer enables inter-network communication. Example, sending data from your home network to a server on another continent. It assigns unique IP addresses. Network layer encapsulates data from the transport layer into packet adding source and destination IP address. There are two types of internet protocol which is known as IP. Network layer uses IP4 and IP6. Example of IP4 is of 32 bytes, while IP6 is made of 128 bytes, and this is the example. While the transport layer is the next layer we are going to handle now, discuss now. Transport layer, this layer identifies any error or corrupted data that is being transmitted over network channel using different method protocol like UDP data and DCP data. Then this data segment is shared over connection and non-connection network services. It also identifies suitable communication channels for the data. The transport layer helps to process delivery. The transport layer also helps in multiplexing and demultiplexing. The transport layer also do the congestion control, flow control, and error control. These are the functions of transport layer. The services of the transport layer include TLS, which means transport layer security, is responsible for providing enhanced security for the transport layer and the network module. It ensures that the external services do not affect the data being handled in the transport layer. One of the TLS services is encryption, which performs encryption procedure for sensitive data handled. And another one is hidden. Many of the TLS services are invisible to the client. And another is compatibility. Most TLS services are available for multiple web browsers and are compatible with multiple devices. All right, I'm going to use Cisco Packet Tracer to show the show physical data and network and transport layer how in one connection. I'm going to use PC. I'm going to use PC. This is PC 0. I'm going to connect this. Then I will use copper straight wire to connect fast Ethernet 0 to this. If you can see, this shows that this is the wrong wire. So I'm going to remove this. Then I'm going to use copper crossover wire to connect. So you see, there's there's green that shows the connection is okay. So I'm going to configure this PC. Okay, I'm going to configure this PC and I'm going to use the IP address 192.168.10.1. So I will get automatic subnet mask. So this is 192.168.10. So this is like the network. I'm going to also configure the other PC1. I'm going to configure the other PC1, PC1 192.168.10. I will name this PC dot 3.
So this is 192.168.10.1. Then this is 192.168.10.3. I just decided to name it 3. Okay. Then I'm going to see if I send message from here to here is going to arrive. Then I'm going to put message here. I'm going to stimulate it. Use stimulation. So you see, the message has been sent from PC0 to PC1, and it is successful. It is successful. So this is to show the physical layer and the data layer, which the data was able to be transferred into frame from here to here, through which I was able to connect the PC0 to PC1 using copper crossover fiber, which is can be also you call like physical layer, because without this physical layer I can't be able to connection of the PC0 to PC1. I can't be able to send the data cannot be able to flow from PC0 to PC1 through frame. So the process of data being converted flowing from PC0 to PC1 is flame. So this is a good example of what I explained earlier in OCI model about physical data, physical layer, data layer, transport layer, network layer, and transport layer. Thank you.
All right. Welcome to part two. First of all, to get the prefix length of um, the network IP address of 172.201.9532, which have subnet mask of 255.255.255.24. So to get the prefix, I'm going to convert the subnet numbers to binary so that I can be able to get the prefix. So right now we have 255.255.255. That is the subnet dot 244.244. Sorry, dot 2224. So the binary number of 255 is 11111 into 8 dot into 8, which is octet 11111, the octet. Then same as the 255, the octet. But I don't know the binary number of 224. So I'm going to get it here now. To get binary number of 224, you have to do it 224 divided by, to get the binary number, divide by 2, we get, sorry, 224 divided by 2 is equals to 112, remainder 0. Then 112 divided by 2 is equals to 112, 56, remainder 0. Then 56 divided by 2 is equals to 28,
remainder 0. 28 divided by 2 equals to 14, remainder 0. 14 14 divided by 2 equals to 14 divided by 2 equals to 7, remainder 0. 7 divided by 2, it will be 7 divided by 2, it will be 3 3.5. So 3.5 0.5 multiplied by 2, it will be 3, remainder 1. Then 3 3 divided by 2, it will be 3 divided by 2, 1. Just like I got 1.5. So you multiply zero point 0.5 by 2, you get remainder 1. So it will become 1, remainder 1. 1 divided by 2, 1 divided by 2 equals to 0, remainder 1. So you take the number from down to up. So it will be 224 will be 1110000. That is the binary number of 224. So now now the prefix will be 8 8 plus, which is the number of ones here, 8 plus 8 plus 8 plus 8 plus the number of 1 here plus 3 ones. So you have 8 octet, 8 ones, octet, 1 8 in this octet, 8, which is total of 27. Total of 27. 27. So the answer is 27. So I'll go here and put the answer 27. So the answer to number one is 27. Then number two, number two, to get the broadcast address, I'm going to use both the subnet mask and the IP address to get the broadcast address. Now let me write let me write the network address down here. I'm going to write the network address down here. Network address is 172.172.201.95.32. 95.32. So this is the IP address. This is the IP address, and this is the IP address. So the subnet mask is 255.255.225.224. So this is the subnet mask. This is the subnet mask. Subnet mask. So to get this, once to get the broadcast, to get the broadcast network, to get the broadcast address, since the subnet is 255, so I'm going to maintain the IP address, which is 172.201.201.95. Then here is not the same. You have 224. So the formula to get this is we use this formula. We use this formula 256 minus the funny subnet, which is 224, which is equals to um, 256 minus 224, but that is 32. So we have to get as close as 32, but since it's 32, the number here 32, so we minus 1. The rule says you have to get at, as close as the number there minus it by 1. So I'm going to minus it by 1, which I'll get 31. So the IP address is 31. So that's the answer. I'm going to put it here. Number 2. So number 3, to get the subnet mask, I will use the prefix length of 25 to get the subnet mask. So it means that I have up to 25. So this means that I have 25, 1, and 7 zeros, making it 32 bit of the octet. So now I'm going to get this. This is 255, 255 dot 1111 is also 255. How I get this 255 is, let me break it down how I get this 255. You convert it back from binary to decimal by you multiply it by you multiply it. Let me do like let me multiply it. You multiply it just like this is 1 to 8. So if I want to get this to decimal, 8, 1, 2, 3, 4, 5, 6, and that's octet. So if I want to get this to decimal, it will be this one will be, because I'm converting it to binary. Two, we start from here. Um, we start from here. 2 raised to power. So 2 raised to power 2, then 2 raised to power 1, then 2 raised to power 3, 2, 2 raised to power 3, then 2, 2 raised to power 4, then 2, 2 raised to power 5. So to show how I get this, to get this converting this binary to decimal, you 1, 1, 1, 1, 1, 2, 2 is to 0, 2 is to 1, 2 is to 2, 2 is to 3, which here 1 multiplied by 2 raised to power 7, 128, 1 multiplied by 2 raised to power 26, 64, 1 multiplied by 2 raised to power 2 raised to power 1 multiplied by 2 raised to power 4, 32, 2 raised to power 5, this is 2 raised to power 6 plus 2 raised to power 2 raised to power 5 plus, so 16. So total is 255. So here we have 255 dot 255 dot 2255 dot 128. So that is the same method I use in getting um, converting the binary to decimal. That is the same method I used in converting this 1000000 to decimal, which is 128. So the answer is 255.255.255.2128. So I'm going to paste it here as my answer, which is here, number three, which is number three. That is my answer. So number four. So number four, my gateway address will be 10.10.78.235.1. So my gateway address will be 128 dot 10.10.78.129. So this is going to be my gateway address. Answer to number four. Then my answer to number five, the binary, converting the IP address to binary, converting IP address decimal to binary. To convert the IP address to binary, which the IP address is 192 dot 192 dot by 5 dot 84.235.0. Okay, dot 84 dot 235.0. Okay, so I'm going to so I'm going to convert this to binary using the same method. When you use the same method dividing, then you get let's divide. Let's divide this. Let's come to 192 divided by 2. 192 divided by 2 equals to 96. 96. Remainder 0. Remainder 0. 96 divided by 2 equals to 48. Remainder 0. 48 divided by 2 equals to 24. Remainder 0. 24 divided by 2 equals to 12. Remainder 0. 12 divided by 2 equals to 6. Remainder 0. Remainder 0. 6 divided by 2 equals to 3. 3 remainder 0. 3 divided by 2 equals to 1.5. But we write 1, then multiply 0.5 by 2, which is equals to 1. Then becomes remainder 1. Remainder 1. 1 divided by 2 equals to 1 divided by 2 equals to 0. Remainder 1. So the binary number for 192 will be, we take from down to up, will be 11000000. So that is, then with the same method, the binary number for 84 will be 10101000. Dot binary number for 235 will be 1110111101011. The binary number for 0 is 0 into octet. So these are the binary number for 192 is 11 1 2 3 110000 into 6. Then for 84 is 101010 10101000. Then 235 111 0 is 000 into 8. So I'm going to put my answer there at number 5. So my answer is too big. So let me reduce it. Yeah, let me reduce it. So that's the answer to number 5. Okay, then number 6. To get the broadcast address of the IP address 192.84.235.0, let me bring it down here. IP address, IP address 192.84.235. 192.84.235.0. That is the IP address. Then the subnet mask is the subnet mask, subnet mask 255.255.255.0, 255, 255, 255. So the broadcast address will be, since 25 255, here is the subnet mask is 255. It's going to be 192. We're going to maintain the network line. We're going to maintain the network line, which is, this is the network line, this is the host, which is 192.84.235. Dot. So the loop says if this is 0, it becomes 255. So since here is 0, it becomes 255. So that is the network. That is the answer to number 6. So that's the answer to number 6. So number 7 is number 7, finding the prefix length of the subnet mask. Okay. So the subnet mask, the subnet mask of, I'm going to convert it from binary to, I'm going to convert from decimal to binary, following the same method. Already know 255 is 1111 octet number into 8. So same 255, 255. So then 192, using the same method I used earlier, is 110. So it means that 255. So it means that the binary number of 255.255.255.192 is 11.2. So that means that the prefix will be 26. The prefix will be 26. This means that we have 26 ones before 0, right? No, 8 plus 8, 16. 8 plus 8 plus 8 plus 2, which is 26. So that means that we have 26 ones and 60. So that's the answer. So that's the answer to number 7. Number 7. Then number 8. So number 8, I'm going to write out the IP address of this to get the broadcast address. The IP address is 172.99.184.64, which is the IP address is 172.99.184.64. 184.64. Then the subnet mask is 255.255.255.190. Subnet mask is 255.255.190. 255.255.255.192. So to get the broadcast address, 255, since is the 255.252 is the network which maintains the network 172 of the IP address 99.184. Then this is the host. So to get this host, we're going to use the formula 256 minus 192. 256 minus 192, which will be 256 minus 192, which is 64. Also 64. So we have 64 here. So the rule says let the number get closer or greater than get closer to the number that is here, minus 1. Assuming this number is 63, I will add it extra 64 plus 64. Then I will minus it by 1. But since it's not like that, I'll just minus it by 1, which is 63. 63. So it will be 63. The host 63. Number 8. So number 9. So to get this binary number, I'm going to use the same method that I used earlier. 205 divided by 2, because it's binary. I'm going to get 205 by 2. I'm going to get 102, 102.5, 102.5, which you multiply dot 5 times 2, which is going to give you 1. So it will be 102 remainder 1. We use the same method throughout. Then 102 divided by 2, which is equals to 51 remainder 0. So 51 divided by 2, which is equals to 51 by 2, 51 by 2, 25 remainder 1, 25 remainder 1. So 25 divided by 2, 25 divided by 2, which is 12 remainder 1, which is 12, 12 remainder 1, 12 remainder 1. So 12 divided by 2, which is equals to 6 remainder 0, remainder 0, 6 divided by 2, which is equals to 3, remainder 0, remainder 0, 3 divided by 2, 3 divided by 2, which is equals to 1, remainder 1. So 1 divided by 2, 1 divided by 2 is equals to 0, remainder 1, 0, remainder 1. So that is it. So um, for 205, the binary number of 205 is 205, 205 equals to 11001101. So for the binary number for 36 is so the binary number of 36 is 100100, and the binary number of 72 is 100100. Binary number of 56 is 111000. So the binary number of the IP address 205.36.205.36.72.56 is one this. That is the binary number. So the answer to number 9 is this. So the IP address of 205.36.72.56, I'll use the IP address and the subnet to get the broadcast address. So here, just like I'll use the same rule. Once it's 255, I'll bring it maintains the network address, which is 205 dot is also 255. I'll still maintain it, which is 36 dot also 255, still maintain it, which is 72. Then the host 248. The loop says 256 minus 256 minus 248 equals to 8. So I'm going to how many times I multiply I add 8 to get something close to 56. So let me say 8 plus 8 plus 8 plus 8 plus 8 plus 8. So I use 8 plus 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 8 is equals to 64. 64. Then I minus 1, which is equal to 63. So here will be 63. 63. That is the answer.